All right, welcome to Lecture 8. We're going to talk today about vectors and parametric equations. So a vector is basically an ordered pair of real numbers, and we denote it in component form as A, comma, B. Now, we don't have parentheses on the end there because that would indicate it was an ordered pair. We have these sort of brackets here to indicate that it is a vector. Okay, so the numbers A and B are the components of vector V, and we call the magnitude of vector V the length. Okay, so the formula for the magnitude is given by this equation right here. That is something that you're going to want to have memorized as we talk about vectors and parametric equations a little bit later on in the school year. Okay, so example 1, we want to find the magnitude of the vector, and so just using the formula, the way that we denote the magnitude is by absolute value bars. That's going to equal to the square root of negative 2 squared plus negative 2 squared. And if you do the arithmetic there, that's going to be 4 plus 4, which is equal to the square root of 8. And if you were to simplify that radical, then you would have 2 square roots of 2. Okay, example B is very similar. We're going to, again, use the formula for the magnitude of this vector V. So that's going to equal to the square root of 5 squared plus 2 squared, which is going to equal to the square root of 29. Okay, so make sure that you know the formula for the magnitude of a vector because we are going to use that when we talk about speed, and particularly when we talk about speed as far as vector-valued functions are concerned. And the formula for speed is just going to be the square root of x prime of t squared plus y prime of t squared, where x and y would be the positions of the particle at any time t, and then of course x prime and y prime would be their derivatives, which would be the velocities. Okay, so this is basically the square root of x prime of t squared plus y prime of t squared. Okay, Roman numeral 2, and what we're going to talk about for the rest of this lecture are parametric equations. In parametric equations, we introduce this third variable called t, which is called the parameter. Okay, and so basically you can think of this parameter as being, for instance, time. And so, for instance, if you wanted to figure out where you were, which ordered pair you were at any particular time, then you would just plug that time into the two parametric equations, which are here, both of which are functions of t, and that would tell you where you were at that particular time t. Okay, so if that doesn't make a ton of sense to you right now, then maybe when we work the examples, it'll start to become more clear. Okay, so example 2, make a table of values and sketch the curve indicating the direction of your graph, and then I'm going to show you how to eliminate the parameter. Okay, so for example A here, we have x of t given by 2t minus 1, and y of t given by 1 minus t. So what I'm going to basically be doing is plugging in these t values into these equations. So in order to get the x value, I'm going to plug t into the x function, and to get the y value, we're going to plug t into the equation for y of t. So if I plug in negative 2 for t into x and to y, then what I'm going to get is the ordered pair negative 5 and 3. Okay, so just plugging in t into both of those equations gives me negative 5 for x and 3 for y. Then if I plot that ordered pair, that's going to be right there. Okay, for negative 1, we're going to plug in that for t into both x and y, so that's going to be negative 3 here, and then positive 2 here, and so negative 3, 2 is going to be here. Okay, if I keep doing this, then what I'm going to end up getting is negative 1, 1, and then 1, 0, and then 3, 1, and 5, 2. Okay, so that's just from me plugging into x of t and y of t. And if I plot those ordered pairs, then my graph is going to look something like this. Okay, so notice that this is a linear function that starts at the point negative 5, 3 and goes through those points as best I can. And it goes in this direction. Okay, so I'm going to draw these arrows on the graph to indicate which direction the graph is going. Okay, so now I'm going to show you how to eliminate the parameter. The way that we're going to do that is just by taking the original equations and solving them both for t and then setting those equal to each other. Okay, so what we have in this first one is going to be x plus 1 is equal to 2t, which means that 1/2 x plus 1/2 is equal to t. Okay, so I just went ahead and divided both of the terms on the left-hand side by 2. Okay, and then in the other equation, we're going to have y plus t is equal to 1, which means that t is equal to 1 minus y. Okay, so if we set those equal to each other, we're going to have, let's see here, 1/2 x plus 1/2 is equal to 1 minus y. If I want to solve for y, then I'm going to subtract 1 from both sides, so that's going to give me 1/2 x minus 1/2 is equal to negative y, so that if I solve for y, I'm going to get y is equal to negative 1/2 x plus 1/2. And now what I want you to do is I want you to notice that our graph is the graph of negative 1/2 x plus 1/2. Okay, notice that the slope of that line is negative 1/2. The y-intercept, which is right there, is positive 1/2. And so you should notice that the equation matches the graph in this particular case, and that's going to happen in all of our examples. Okay, example B here, we have x is equal to the square root of t and y is equal to t plus 1. Okay, so if I again plug in these t values into x and to y, then what I'm going to be getting is 0 and 1. If I plug in t equals to 1, the square root of 1 is 1, and then 1 plus 1 is 2. If I plug in 4, the square root of 4 is 2, and the 4 plus 1 is 5, and then the square root of 9 is 3, and 9 plus 1 is 10. Okay, so if I go ahead and plot all of those points, I have 0, 1, I have 1, 2, I have 2, 5, and then 3, 10 is going to take me off the graph, so I'm just going to kind of estimate there. Okay, and so here's my graph, and then the direction is going up. And that's because, excuse me, our first point was at 0, 1, and then our points after that started going up. Okay, so now if we want to eliminate the parameter, we're going to start with our original equations. We're going to solve both of them for t. And so what I'm going to get here is x squared is equal to t. And actually what I'm going to do, instead of doing that, something to make it a little bit easier, I'm just going to substitute that in for the equation for y. So if I substitute that into the t there, that's going to say y is equal to x squared plus 1. And so what you should notice is that that does match, in a way, the graph that we drew. But unfortunately, in our picture, we only have the right-hand side of the parabola. So what we have to do is we have to restrict x so that it is only greater than or equal to 0. And there we have our solution in what is called rectangular form. It started in parametric form, and we ended in rectangular form. So this right here would have been our answer if we were trying to eliminate the parameter, and then right here is the graph. Okay, example C, we have x of t is equal to t squared minus 2, and y is equal to t divided by 2, and we're restricting t to only be between negative 2 and positive 3. Okay, so I'm going to let you kind of do this part on your own, but I am going to fill this in, these points here. So you have 2, negative 1, negative 1, negative 1/2. We also have negative 2, 0, negative 1, positive 1/2, 2, 1, and 7, 3/2. Okay, so if we plot those points, we're going to start at 2, negative 1, which is going to be right there. Negative 1, negative 1/2, which is here. Negative 2, 0, which is right here. Then we have negative 1, positive 1/2, which is there. 2, 1, which is right there. And then finally 7, 3/2, which is all the way over here. Okay, so what we have is kind of this sideways parabola, and I'm going to try to do my best to draw the graph that goes through those points, this sideways parabola which is going in this direction. Okay, so now if we try to eliminate the parameter, what we're going to do is we're going to solve y of t for t. So we start with y is equal to t over 2. We're going to solve that for t by multiplying both sides by a 2. And then we're going to substitute that into the other equation. So x is going to equal 2y squared minus 2, which means that x is equal to 4y squared minus 2. And notice that this is the equation of a sideways parabola. But again, we need to restrict the range for y. And so the range for y would be from -1, since that's the smallest y value on the graph, and then the biggest y value on the graph is going to be 3/2. Okay, example D, our last one here, we have x of t is equal to 3 plus 2 cosine of t, and y is equal to -1 plus 3 sine of t. And I've kind of done it this way so that the unit circle kind of works out well here. So if we plug in 0, then what we're going to get is the 0.5 -1. If we plug in pi over 2, then we're going to get the 0.32. Plugging in pi is going to give me 1 -1. If I plug in 3 pi over 2, then that is going to give me 3 for x and -4 for y. And if I plug in 2 pi, then I'm going to again get 5 and -1. Okay, so plotting all of those points, let's start with 5, -1. We're going to actually be plotting that one twice. So 5, -1 is here. 3, 2 is going to be right there. 1, -1 is here. 3, -4 is way down here. And then we go back to 5, -1 again. And so what we have here is what's called an ellipse. So an ellipse is a lot like a circle, but it is either stretched in the vertical or in the horizontal direction. And so our graph is going in this direction, since that was the way that we plotted the points. Okay, in order to eliminate the parameter, this one is a little bit different. We are going to solve for cosine of t in the x equation and sine of t in the y equation. So if I solve for cosine of t in the x equation, what I'm going to get is cosine of t is equal to x minus 3 divided by 2. And if I solve for sine of t in the y equation, then what I'm going to get is y plus 1 divided by 3. Now I'm going to use the trigonometric identity that you should have learned in pre-cal. Cosine squared t plus sine squared t is equal to 1. Okay, so if I square cosine, that's going to say x minus 3 squared over 4. Plus, if I square sine, that's going to give me y plus 1 squared over 9 is equal to 1. And this is the equation for the ellipse that is centered. It has a center at 3, -1. And that's because of this part right here. This x minus 3 means that the x value of the center is 3. And then because that says y plus 1, that means that the y value of the center is going to be -1. And if you notice, 3, -1 is right here, and that is the center of our ellipse. Okay, if you guys have any questions on vectors or parametric equations, do not hesitate to contact me, and I'll be more than happy to help you out.